Welcome to qnawire.
For part A, we want to figure out the height that the rocket achieves under these conditions. Time is 10 seconds, acceleration is 2.8, the initial position is ground level, and the initial speed is 0. To do this, we can use the kinematic equation x minus x naught is equal to v naught times t plus 1/2 times the acceleration times the time squared. So since x naught is 0, that term goes away. And we're left with 1/2. This term also goes away. 1/2 times the acceleration, which is 2.8, times the time squared. So we get 10 squared. This ends up being 140 meters. So for part B, I think the first step we want to do is figure out what the velocity is after 10 seconds. So we're going to use v squared is equal to v naught squared plus 2 acceleration x minus x naught. And we're going to figure out what v is after 10 seconds. So v naught is 0. So v squared is equal to 2 times 2.8 times x minus x naught, which is now 140. That leads to v being 28 meters per second. Now that we know what the velocity is after 10 seconds, we can use that to figure out what the velocity is when the height is 325 meters. So we know v naught is 28 meters per second. We know that a is 2.8 meters per second squared. And when I read the problem, I interpreted the engine as continuing to keep burning after 10 seconds, although it is kind of confusing. If it turns out that the engine is not active after 10 seconds, then you would replace this value with negative 9.8 and do the rest of the calculation the exact same way that I'm about to do it. I just couldn't really tell what the problem was asking, so I went ahead and kept this as 2.8 and assumed that the engines were continuing to go. X naught is 140 meters, and x is 325 meters. Our unknown is v. So to do this, I'm going to use v squared is equal to v naught squared plus 2 acceleration x minus x naught. So we plug in v naught is 28, we square that out, we add that to 2 times 2.8 times 325 minus 140. This becomes a calculator problem at this point. And then you square root it to get 42.7 meters per second. And that should be the speed once the rocket gets to 325 meters above the ground.